Alright, dear students, welcome back to yet another session from sisyaclass in this series that is Ultimate Bridge series, which we have started to help students that are moving from grade 9 to grade 10. Now, we have already uploaded so many videos of grade 10 chapters. If you haven't watched them, make sure you watch them right now. You can check out our channel or check out the description box below. All the links are provided there. Alright, so just a reminder that this series is going on in three different languages. That is, if you want to study in Hindi, you can watch Shikhi Sir class. If you want to learn in Telugu, you can obviously watch Kaushik Sir class. All right. So in this class, what we are going to cover is surface area and volume. Now, this is nothing new. Why? We have studied this same surface area and volume in grade 9. And this chapter for sure contains all the formulas that you've studied in grade 9, all the concepts that you've studied in grade 9, and the same will be applied in grade 10 as well. Right? All right, without further ado, let's start. So let me just introduce myself if you don't know me yet. So my name is Rishabh. I am Maths Master Teacher here at sisyaclass. I have completed my education from IIT Jodhpur. All right, so I hope you know this. But what if you don't know this? I'll tell you one more thing. But first, in grade 9, what we studied? In grade 9, we studied some formulas like cube, cuboid, cone, sphere, hemisphere, and their volume and surface area. If you don't know that, I will just quickly recall them before we move forward. Next, we all in grade 10, what we are going to study is combination of solids. Combination of solids means we are going to study the surface area of the combination of solids. Combination means nothing. If I join, let's say two surfaces or two solids, I will get one combination, right? And we are going to study the surface area volume, addition and subtraction of obviously for surface area and volume, and conversion of solids. That is how one solid can be converted to another solid. So I hope everyone is ready with notebook and pen. All right, let's start. But before I start, first of all, I would like to tell you about this program which I've been telling for so long. This maths 1 year program for grade 3 to 10 is up and running. The classes are starting from May 5th, and the seats are filling very, very, very fast. And this, the best part is the original price is rupees 10,000. But if you're enrolling right now in the offer, you're going to get it in just rupees 999. That is for one complete year, not for 1 month or something. It is for one complete year, 999. All the sessions will be taken by IIT and NIT teachers, and you will be getting access to Sysya AI. Now, what is Sysya AI? Sysya has developed their own AI. So I hope you all are familiar with this. What is AI? We are all in AI generation, right? So you can get your doubts cleared via if you want to ask any doubt, you can just type it, you get the answer. Suppose if you're too lazy for that, you can just speak, and you will get the answer. And suppose if you want to scan a question, suppose if that is difficult, you scan the question and you will get the step-by-step solution for that. All right, you can scan this QR code and start your journey with us. All right, okay. So first of all, suppose if I ask you to find what is the volume of this tent. Now, how will we go about it? Now, is it a familiar figure? No. Is it a cone? No. Is it a, let's say, cuboid? No. But I can break this, right? If I see this is a cylinder, right? And this upper part is a cone. So this is made up of two solid figures that you're familiar with, that is cone and cylinder. So if I add the volume of both cone and cylinder, wouldn't I get the volume of the entire solid? Yeah, that's what I was talking about. And we will be dealing more this in the detail part. Don't worry about it. So in today's, first of all, volume and surface area formula for all shapes, I'm going to recall this. You should be knowing because you have studied in grade 9. Then we'll move to combination and conversion of solids. All right. So if you don't know, dear students, we have lateral surface area. First is LSA. It is also known as CSA. We have TSA, that is total surface area. Right, and then we have volume as well. Now, what is a difference between LSA and TSA? The only difference is if we leave the upper two parts, that is top and bottom, we will get LSA. And if we consider all the parts, we'll call it TSA. For example, if you're sitting in a room right now, room is in the shape of cuboid. If we consider the surface area of only the four walls, if you consider walls of area of wall, only the four walls, what we are going to get? We are going to get lateral surface area. And if I include top and bottom also, I'm going to get total surface area. Now, these are some formulas. You can pause the video right now and note it down. What is cube? What is the surface area for cube? It is 4a square. Total surface area is 6a square. For cuboid, it is 2h times L plus B. And for TSA, for cuboid is 2 times LB plus base plus HL. For cone, it is pi RL, where L is what? L is slant height. Right, slant height. And how will you calculate h square plus r square? Using Pythagoras theorem. We have done so many questions in grade 9. I hope this is clear. And total surface area is nothing but pi RL plus pi r square. If I take pi r common, I will get pi r times L plus r. I hope it is clear. Great. For cylinder, what we have for cylinder, we have LSA is equals to 2 pi RH and TSA is 2 pi R times R plus H. Again, same thing, 2 pi RH is the lateral surface area. If I include top and bottom, that is top is also circle, bottom is also circle. That is 2 pi RH plus pi R square plus pi R square, or 2 pi RH plus 2 pi R square. 2 pi R I will take common multiplied R plus H. For sphere, what is LSA? It is 4 pi R square, and TSA is also 4 pi R square. Why? Because can you find, if you take a ball, can you find what is top, what is bottom? It's not defined, right? So LSA and TSA for sphere is both the same. Hemisphere, if we cut sphere in half, LSA I'm going to get 2 pi as well. But here I have generated one top surface as well, that is circle. So TSA will become 2 pi R square plus R square, pi R square. I hope it is clear. Right, these formulas we have studied in grade 9, and dear students, these are 5-star formulas in grade 9 as well and in grade 10 as well. So what do you have to do for 5-star formulas? Just write it down in a, let's say, take a good chart paper, write down the formulas, because this chapter is very important. See, in order to get maximum marks in this chapter, what you have to do, first thing first, you have to know all the formulas. Second of all, you have to be very precise in calculations, nothing other than that. This chapter is very easy. If you know all the formulas and your calculation is strong, you will get 100 on 100 on this chapter. All right. Okay, let's start. So first, I'll discuss one topic, that is surface area of combination of solids. Okay, so let's start with the questions. I hope with the questions you get the better clarity. The first question says 3 8 centimeter cubes are joined edge to edge. 3 8 centimeter cubes are joined edge to edge. Find the surface area of the resultant shape. Okay, so whenever I have these problems, see, I will not apply my mind. I will shut off my mind for some time. I will just focus on what the question is saying. 3 8 centimeter cubes are joined edge to edge. That is, if I draw, this is one cube, right? This is another cube. Okay, this is another cube. Okay, so these three cubes, this looks like a cuboid, but consider it as a cube only. So these three cubes I have joined edge to edge. Okay, what is the length? What is the side 8? That means this is 8, this is also 8, this is also 8. If I consider breadth of the cube, same 8. No, for cube, length, breadth, and height are all same side. So this is 8, this is 8. Now, can you tell me what is this figure? This figure is a cuboid, right? So if I join two or more cubes, I will get always and always a cuboid. Okay, can you tell me what is the length of this cuboid? The length of this cuboid is 8 plus 8 plus 8. That is 24 centimeters, right? What is height? Height is this. Height is same as 8. Okay. What is breadth? Breadth also same. That is 8 centimeters. So I have height as 8 centimeter, breadth as 8 centimeter, but length changes. See, that is the thing. If I'm joining edge to edge, the breadth remains the same, the height remains the same, but length changes and it will become 3 times. Now it is a cuboid. What is the formula for cuboid? If I have to find TSA of cuboid, it is 2 multiplied by LB plus BH plus LH, right? Very easy. Now length is what, 24. So 2 times 24 into 8 plus 8 into 8 plus 24 into 8. Right. Length is 24, h is 8, b is 8. So if I try to simplify this, I will get 2 times, this is 192 plus 8 times 8 is 64 plus 24 times 8 is again 192. I will do it in the next page. So TSA, you understood this, right? If you have any issues, you can let me know in the comment box below. So what will it become? 2 multiplied by 384 plus 8 times 8 is 64. Now just solve it. You will get the answer as 896 centimeter square. So this is the TSA of the resultant figure. And what is the resultant figure? Then this case, resultant figure is cuboid. Right? So if I'm joining 3 cubes, I'm going to obviously get a cuboid. But the important point is the height and the breadth will not change. Length will change, of course, right? It will increase. Great. Okay, let's do this question. Now, this question is from NCERT only. This is a NCERT question, pretty straightforward. You have to find the surface area, or not R, surface area of the given figure. Now, if you look this figure in 2D, it is a triangle and a semicircle, but this is a 3D figure, right? So, suppose in the question it will be given that it is cone or it is a sphere or anything. But if you see the front view, we can imagine that this is nothing but a cone and this is nothing but a hemisphere. Correct. All right. So if I have to find surface area, it will be given by curved surface area of hemisphere plus curved surface area of cone. Easy, nothing other than that. All right. Okay, let's find for hemisphere. For hemisphere, first of all, I am finding for hemisphere. So CSA of hemisphere. What is the formula for curved surface area of hemisphere? Remember, 4 pi r square is the total surface area of sphere. If I'm cutting it in half, it will become 2 pi r square. That is 2 times pi times r square. I will leave it as r square for now. Next, what is CSA of cone? CSA of cone will be, remember, CS of cone is given by pi times r times L. Now, do we have L here? No, we don't have L, but we can find, right? Okay, how will I find L? Just see. If I have this triangle, just consider this triangle. Okay, this, first of all, height is given by what? Total height is 5. Total height is 5, and this is diameter is 3.5. Can I say this height is radius, that is 3.5 by 2? Yes or no? Right. So what is the height becomes? It will become 5 minus 3.5 by 2. We will solve, do the calculations in a while. So height is 3.5 minus 3.5 by 2. And what is radius? Radius I know is 3.5. Right. 3.5 by 2. Radius is 3.5 by 2. So if I know radius, so L is given by square root of h square plus r square. H I have found 5 minus 3.5 by 2. If I solve it, it will get 6.5 by 2. Right. And R is what? 3.5 by 2. So if I calculate this, L is equals to square root of 6.5 by 2 whole square plus 3.5 by 2 whole square. And if you simplify this, you will get somewhat 3.7 centimeters. Clear? Up till now, is it making sense? How I found L 3.7 centimeters. Okay, now let's add. We have to find total surface area, that is 2 pi r square plus pi into r into, I have found 3.7. So I will write 3.7. Now, why I'm not simplifying this further? Because I can take something common. So I will get pi and r common. I will get 2r plus 3.7. Yes or no? Because pi r I have taken common. Now pi into r. What is r? R is 3.5 by 2. Right. So 3.5 by 2 into 2, I will get 3.5 plus 3.7. Right. Now pi I can write as 3.14 or 22 by 7, whatever you want. Whatever is specified in the question. R is 3.5 by 2. If I add this, I will get 3.5 plus 0.7, 4.2 into 7.2. So if you find this, you will get answer as 39.6 centimeter square, or you can approximate it to 40 centimeter square. Be very, 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 very cautious of the unit. If it is area, the unit has to be in square centimeters or centimeter squares. So make sense how we did this question? Nothing other than that. No, we have just to add both the surface areas, curved surface area. That is important. All right. Let's look at one more question. Now, this chapter is nothing. You have all the formulas understood in grade 9. If you have memorized it and if you understand this, it's just application of the entire grade 9 chapter. Okay, what is the question saying? A cubical block of size 7 centimeter is surmounted by a hemisphere. First of all, what is the meaning of surmounted? What is the meaning of surmounted? Surmounted means suppose if I have one object and this object is placed above the other object. This is called as surmounted. Okay. So what is the greatest diameter of the hemisphere we can have, and we have to find the surface area. Okay, again, brain is shut off. I will just do whatever the question is telling me to do. So I have a cubical block. I will draw a cubical block. I know my drawing is not good, but I hope you get the gist of it. Okay, this is very bad, but it's okay. Okay, a cubical block of size 7 centimeters surmounted by a hemisphere. So hemisphere will be somewhat like this, right? Yes. What is the greatest diameter? So for to understand it, I will also draw a top view. So this is the top side of the square. And on this, I have the base of the hemisphere like this. Here. Now, what is the side of cubical block? It is 7 centimeter. So first question, what is the greatest diameter that the hemisphere can have? Greatest diameter is nothing but this, right? So greatest diameter, I can say that D maximum or D is equals to 7 centimeter in this case. Clear up till now? Yes or no? Okay. Now we have to find the surface area of the solid. Now, in order to this, you have to visualize it. Okay. Now, okay, bring your brain back on. What we have to do, we have to apply our brain now. See, if a cube is there, okay, imagine if a cube is there, okay, imagine using this cuboid, okay. Now, if I'm putting some sphere on the top, what will happen? What can I say? I can say, let me write it here, that TSA of the resultant solid will be TSA of cube, okay, minus area of base. Now, why I'm subtracting area of base? Because see, this part and this part is still included, right? So we have to remove this part, but these parts we have to consider. So I will write TSA of cube minus area of base plus CSA of hemisphere. Correct. Right? Hemisphere we have to consider. Now, what is total surface area of cube? It is 6a square. Right. Minus what is area of base? It is pi r square. And what is CSA of hemisphere? It is 2 pi r square. Right. I will just simplify this. I will get 6a square plus pi r square. 2 pi r square minus pi r square, pi r square. Now, what is a? A is what? 7. 7 square. What is pi? 22 by 7. And what is r? R in this is the side is 7 centimeter. R is going to be 7 by 2 into 7 by 2. So 7, 7 will get cancelled. This is 11. So what I'm going to get 6 times 7 square is 49. That is 6 into 49 plus 77 over 2. If you solve this, you will get answer as 332.5 centimeter square. Just for all the calculations, dear students, please do it on your own and cross verify with the answers. Great. All right. Let's move forward. Okay. Before we move forward, one question. Think and answer. Okay. Can you increase the surface area of a solid by creating a cavity? What is meant by cavity? If I suppose if I have let's say if I have a cube, okay, can I increase its surface area by removing some part? Yes. Why? Because suppose if I create a cavity like this, okay, some new surface will be creating, right? I will help you better with the help of an example. The question is, from a solid cylinder whose height is this and diameter is this, a conical cavity of the same height and the same diameter is hollowed out. Find the total surface area of the remaining solid to the nearest centimeter square. So what does it say? Again, I have to first draw the diagram. So I have a solid cylinder, something like this. Right. Now from this, I am creating one cavity. A conical cavity of the same height and same diameter is hollowed out. That is somewhat like this, right? Okay, this is hollowed out. That means this part is not there now. We have to find the total surface area. Now, dear students, see, in this case, can I write? I have to write TSA of the total, that means of the remaining shape, will be first CSA of cylinder, CSA of cylinder plus CSA of cone plus one more thing is there, that is area of circle. Now, I will help you understand this. See, first of all, you understood the situation, right? There is a cylinder and I have created one conical cavity on this. Now, have you seen a spray paint? Anything, a spray paint, a paint. Now, suppose if you have to paint the outer dimensions of this figure, what I will do, first of all, I will paint this top part. I'll start with this. Okay, this is first. It is covered, area of circle. Second, what I will do, the outer part of the cylinder, that is the curved surface area, that is 2, right? But I have one more surface here, that is the inside. I have to paint inside as well, right? So this becomes the third part, that is CSA of cone. Now, if you have understood it, now comes the manual part, that is the formulas. What is CSA of cylinder? That is 2 pi RH. What is CSA of cone? Pi RL. And what is area of circle? Pi R square. Right. Now, first, let me just take everything common. I will take pi common. I can take R common. I will get 2H plus L plus R. Now what we have? H we have 2.4. R we have 1.4 by 2. That is 0.7. But do we have L? No. So let's find L. So how will I find L? Again, L is given by the formula R square plus H square. Now R is what? Radius is 0.7 square plus height is 2.4 square. Right. Now 24 square is what? 496. 496 plus 49. This is nothing but 6.25, and I can write the square root is 2.5 centimeters. Remember, these are Pythagorean triangles 24, 7, and 25. So I have found my L also has 2.5 centimeters. Now what? Again, same formula, that is pi is what? 222 by 7. R is what? R I have found zero point 0.7 times 2h, that is 4.8, plus L I have found 2.5 plus R, that is 0.7. If you find this, please do the calculations on your own. I am writing the final answer here, that is 17.6 centimeter square. Is it clear now? Yes. So in some cases, the surface area of the solid can increase as well. Why? Because whenever I'm cutting something, new surface areas are creating. Great, awesome. Let's move forward. Now let's move to the volume of combination of solids, and this is the very easiest part. Surface area, I know it can be a tricky. Volume, nothing is tricky. Let's start with the first question only. Three 8 centimeter cubes are joined edge to edge. Find the volume of the resultant shape. Okay, then again I will draw the diagram. One, two, three, and they are joined right like this. So what is length? This is 8, 8, and 8. So what does length become? Length become 24 centimeter. Right. What is height? Height is what? 8 centimeter. And what is breadth? Breadth means see, that is 8 centimeter. So volume in this case will become, what is the volume of cuboid? LBH. L is 24, height is 8, H is 8. So if I calculate this, that is 24 multiplied by 64. If you do the calculation, you will get 1536 centimeter cube. This is volume now, so it is in the form of cube. Clear? Right? Again, same thing. But observe one thing here. What I want you to observe, if I found, let's say, what is the answer? I found the answer 1536. If what is the volume of one cube? It is a cube. What is the, if we have three such cubes, what is the volume? 3a cube. What does that mean? That if I'm stacking the three cubes together, that is the volume is equal to the three cubes. Why? Because in case of volume, we don't have to do anything. You're getting it, right? All right, clear. Okay, let's move to another question. If you think my speed is a bit fast, you can let me know in the comment box below. I'm moving forward because this is for just the questions we are doing, and I'm hoping that you are understanding all the concepts. Yeah. Now, what is given? A solid is in the shape of a cone standing on a hemisphere. Okay, what is happening? A solid is in the shape of a cone which is standing on a hemisphere with both their radii being equal to 1 centimeter and height of the cone is equal to the radius. Wow, everything is given and it is asking the answer in terms of pi. See how easy this question is. What is it? We have a cone standing on a hemisphere. That is, if we have a cone like this and it is standing over a hemisphere like this. Clear? Okay, now both radii is equals to 1 centimeter, that is, this is 1. And the height of cone is also given. Very nice. Height of cone is equals to its radius, 1 centimeter. Now what should we do? Entire thing is given that volume is equals to volume of cone plus volume of hemisphere. Right? What is volume of cone? Pi r square h over 3 plus what is volume of hemisphere? 2 by 3 pi r square h. Right. Now 2 by 3 pi r square h plus pi r square h. If I take the LCM, what will it become? Pi r square h plus 2 pi r square, that is 3 pi r square h over 3, which is nothing but pi r square h only. What is radius? 1 centimeter. What is height? 1 centimeter. Put the value, get the answer. Pi into 1 into 1, pi only. So what is the answer? Pi centimeter cube. Nothing. Very easy question. I'm writing the final answer here. Pi centimeter cube. Clear? See, such easy question. What do you want? Okay. Let's do some difficult question. I'm not enjoying this easy questions. Let's do this question. Well, it's not difficult, but yes, it involves something. First of all, read the question. A gulab jamun, okay, I'm already hungry, contains sugar syrup up to about 30% of its volume. That means, and you have this gulab jamun right now. It is not made up of entirely sugar. It has some other things also. I can upload the recipe video as well. Don't worry. So the thing is, it has some part of sugar, some part of other stuff. But what is given, that sugar syrup is 30%. Okay. Now we have to find approximately how much syrup would be found in 45 gulab jamuns. So suppose if someone ate 45 gulab jamuns, how much sugar syrup he has eaten, that you have to find. Now, what is the shape of gulab jamun? It is also telling. It is shaped like a cylinder with two hemispherical ends, length 5 centimeter, diameter 2.8 centimeter. I hope everyone has seen a gulab jamun. It will look like this. Everyone has seen. The end is what? Hemisphere. And this is what? Cylinder. Okay, now it is giving you everything. The length is given 5 centimeter, right? And the total length is given 5.8, 5 centimeter, not just the cylinder part. And what is the diameter? Diameter is given 2.8 centimeter. Okay, now we have to find volume. Three parts. First part, second part, third part. First part is hemisphere. So I will write total volume is volume of hemisphere plus volume of cylinder plus volume of hemisphere. Again, three parts. That is 2 times volume of hemisphere plus volume of cylinder. Right. Now I will write it here. So total will become, see here, total will become, what is volume of hemisphere? 2 by 3 pi r cube. If I multiply by 2, that is 4 by 3 pi r cube. Right. Plus what is volume of cylinder? Pi r square h. Now, do we know r? R we know is, if diameter is 2.8, r is 1.4. Don't do this mistake. Okay, again, never. I'm again telling you, don't do calculation mistake. So r I know is 1.4. Do I know h also? Yes. See this. This is equals to radius. This is radius of hemisphere. This is also radius of hemisphere. So I can say h is equals to, let me do it here. H is equals to 5 minus 2r. 2r I know is 1.4. That is 5 minus 2 into 1.4. That is 5 minus 2.8. What is 5 minus 2.8? It is nothing but 2.2. Right. So I have found h. Do I have r? R I have 1.4. Next, what? If I have everything, what I'm waiting for, just apply the formula. 4 by 3 pi r cube. So volume is equals to 4 by 3 pi r cube plus pi r square h. Can I take something common? Of course, yes. So I will take common. So I'll get pi r square. I have taken common 4 by 3 r plus h. Now pi into 1.4 whole square times 4 by 3 times 1.4 plus 2.2. Now, will I do the calculation? Of course not. But will I tell you the answer? Yes. Answer I will tell you. Wait, something happened. Just give me a second. This volume of combination. Okay, this we have done. This is very easy. So the final answer, yes. So this is the answer. If you calculate this, you will get the answer. Tell me the answer in the comment box below. All right, great. Amazing. Now, one question. Can you increase the volume of a solid by creating a cavity? What do you think? Now, so in the surface area, we can increase the volume, right? We can increase the surface area, but can we also increase the volume of a solid? Let's understand this with the help of an example. Again, from a solid cylinder, height this, then diameter this, it is the same question we did before. I'll read the question one more time. From a solid cylinder whose height is 2.4 centimeter, diameter is 1.4 centimeter, a conical cavity of the same height and the same diameter is hollowed out. We would find the total volume. That means we have this thing, solid cylinder. A conical cavity is carved out, or like it is a conical cavity is generated. We have to find the volume. So volume is this time volume. See, volume you can see by considering, suppose if you have a glass, if you're making a hole in this, if you're putting some water in that, will the water flow out? Yes, that means volume will reduce, right? What is volume of, it will be volume of cylinder minus volume of hemisphere. What is volume of cylinder? Pi r square h minus, not hemisphere, this is cone. What is volume of cone? 1 by 3 pi r square h. So what is the answer I'm going to get? It is with 2 by 3 pi r square h. If I do the calculation here, it will be 2 by 3 multiplied by pi, that is 22 by 7, into r. R is what? 1.4 or 0.7? 0.7 r square into h, that is 2.4. Now you can do the calculation. Answer you will be getting is 0.41 centimeter cube. So no, the answer for this question is that no, we cannot increase the volume of a solid by creating a cavity. I hope it is clear, right? Okay, let's move on to the another topic, that is conversion of solids. Now, a disclaimer that this has been removed from the new updated syllabus, but still for better information, for better understanding, we are going to solve 2 to 3 problems, and one problem I will give you as a homework. Alright, what does conversion of solid means? First of all, have you ever seen an ice? Right. Suppose if I take ice and I in the under the ideal condition that no matter is lost, if I create an ice and let it melt, can I say that the volume of the ice that I have created is equals to the volume of water under ideal conditions? Now, I'm not considering that some is evaporated, whatever that. No, nothing is evaporated. So in that case, volume remains same, right? So this is the concept that we are going to do. Okay. Now let's see. A silver sphere. Oh my God, silver, expensive. A silver sphere with radius 24 centimeter is melted down. What we did, we took a silver sphere 24 centimeter, we melted down and recast it into 30 smaller spheres of equal size. We have to find the radius. Now, first of all, if I take one big sphere and I melt it down, I've got some small spheres. How many we've got? We've got 30. We have to find the radius. But what is that? The volume remains the same. That is volume of one should be equals to volume of two. Right. Now, this is volume of a smaller sphere. And the how many we have? 30. So one relation we have that V1 equals to 30 times V2. Now, what is V1? If we consider sphere, the volume is 4 by 3 pi into R. R is what? 24 Q is equals to 30 multiplied by what is volume? Again 4 by 3 pi, but R we know. No, R cube. 4 by 3 get cancelled. What is 24 cube? 24 into 24 into 24 over 30 is equals to R cube. That means our R will be equals to 24 over cube root of 30. Of course, you can estimate the cube root of 30, but it's okay. For in this case, you just understand the concept. Clear? All right, let's look at the next question. How many cylindrical candles 2 centimeter in diameter and thickness 2.5 millimeter? Now see what is it given? Cylindrical candles diameter is centimeter and thickness is very small. So 2 centimeter diameter. Okay. So diameter I have is 2 centimeter. Thickness, or I can consider this as height, is 2.5 millimeter. If I convert it in centimeters, what is 2.5 millimeter in centimeter? That is 25 centimeter. Why? Because in 1 centimeter we have 10 millimeters, right? So it will be, if I have to get 1 millimeter, it will be 0.25 centimeter. Clear? Can be melted to form a cuboidal candle of dimension 6 centimeter into 11 centimeter into 4 centimeter. So what we have to do again, I don't know volume, so I will assume N into volume of candle is equals to volume of cuboid. Right. So N, I will do it here. N into what is volume of candle, since it is in the form of sphere, pi into R square into H is equals to volume of cuboid, that is L into B into H. Right. Now N into pi I know. R is 1, since D is 2, R is 1. 1 into 0.25 is equals to, what is it? 6 into 11 into 4. Now, what do we have? If I solve this, I will solve it here. So it was N into pi into 0.25, I will write 1 by 4 for my calculation. And this is equals to 6 into 11 into 4. Now, again, same thing, N is equals to 6 into 11 into 16. 4 times 4 is 16 over pi. Solve this and tell me the answer. Very easy. Just again, I'm telling you nothing is there. We just have to perform the calculations very smoothly, very carefully. Clear? Great. Okay, one more question, and perhaps the last question for this. The question is: three metallic spheres with radii 7 centimeters, 9 centimeters, and 11 centimeters are melted down to create a single solid sphere. What is the radius? So we have three spheres. Radius is R1 is 7, R2 is 9, and R3 is 11. They are melted down to form a single solid sphere. That is, volume remains same. That is V1 plus V2 plus V3 is equals to volume of the final sphere. What is the volume of sphere? 4 by 3 pi R1 cube, that is 7 cube, plus 4 by 3 pi R2, that is 9 cube, plus 4 by 3 pi 11 cube is equals to 4 by 3 pi R cube, which I don't know. But 4 by 3, 4 by 3 pi, 4 by 3 pi, 4 by 3 pi cancel. So if I write it here, I will get 7 cube plus 9 cube plus 11 cube is equals to R cube. So the final R will be the cube root of 7 cube plus 9 cube plus 11 cube. Again, this type of calculation, that's why this is not in the syllabus right now. But again, this is for your knowledge and only. So I hope you understood everything, right? Whatever we have discussed up till now. Great. All right. Again, dear friends, once again, a reminder that this offer is going on only right now. And I know we are just covering the superficial topic because this is just the ultimate bridge series which we have started. But for the better understanding, and we are giving this offer in just rupees 999. And May 5th is approaching very fast. The seats are filling very fast. We are almost closing the admission. So if you are interested for this, please scan here. You can check out the profile for the teachers. Also, we are all IIT and NIT teachers here. The reason why we are giving this in such a low price is we want the benefit for the children. We are just aiming for that right now, right? So this is for 1 year program powered by Sysya AI as well. All right, check out the link in the description, or you can scan the QR code right in front of you. Either way, I will hope to see you there. All right. And thank you, dear students. Thank you so much for joining. Again, one more chapter we will be left, the statistics that will be coming tomorrow live. All right, bye bye.